Hello and welcome once again to Captain Goodspeed Maths. I'm Joe if you're new around here, and today we are continuing with the OCR FSMQ new specification, content, and in particular integration. So learning objective today is to use differentiation to work out the stationary points of curves apparently. But it's not. It's actually to learn about integration, which is another form of calculus, which we talked about over the last 3 lessons. We talked about differentiation. So today we are going to talk about integration. So first of all, let's get into it. So we can differentiate, which is what we've talked about the last 3 lessons. We know that as long as we have the name of a graph, then we can perform something known as differentiation, which helps us find the gradient of a curve at any given point. So y equals ax to the n. If we have that, then we know that dy by dx is equal to na x to the n minus 1, which is bring the power to the front, knock 1 off the power. Well, we want the opposite of this, so let's have a look at this. Integration then. Integration is the opposite of differentiation, so if you can differentiate, you can be pretty confident that you'll be able to integrate too. Just remember the one thing, which is the constant of integration. So to integrate a piece of algebra, if we have dy by dx is equal to x to the n, then the integral, that is the integral sign there, that funny S shape, of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. So name of graph differentiated is that. We integrate with respect to x, and the answer is add 1 to the power and divide by the new power, i.e. if the power is 1, add 1 to make it 2, then divide the whole thing by 2. So, you know, again, just like differentiation, we will sort of make it easier when we look at examples. But don't forget this c, and we'll talk about that in a minute. So find the integral of the following. So we have dy by dx is equal to 3x squared. So what we're going to do is integrate 3x squared with respect to x. So we get 3x cubed over 3, add 1 to the power, divide by the new power, which is x cubed plus c. Do not forget your c, that is a constant of integration. And that all comes from before, if you remember, when we differentiated a constant, say 9 or 4 or 1 or 3.5 or 7.2, it would differentiate to 0. So when we go the other way, we need to account for that. So we add on a constant, which if we differentiate back, that constant washes away. So the power 2 rises to power 3. So similarly, if you have 4x cubed, we add 1 to the power, divide by the new power, and we get x to the 4 plus c. 12x to the 5, we do the same. We get 12x to the 6 over 6, which is 2x to the 6 plus c. Power 5 rises to power 6. 7x there, so we get 7x squared over 2 plus c. Power 1 rises to power 2. And the integral of a constant is 9x divided by 1, because remember, that is an artificial 1 there. That is an artificial x to the 0, so we add 1 to the power, divide by the new power. So it's 9x plus c. So power 0 rises to power 1. So, remember that c that we were adding? Well, sometimes we're asked to work out what it is. How on earth are we going to do that? I hear you say, well, the examiner won't throw you in blind. He will give you a little bit more information about the curve in addition to its derivatives, such as the coordinate, and then we're in business in terms of finding c. So remember, we differentiate y to get dy by dx, and then we integrate dy by dx to get y again. So, example 1 then. The curve f of x goes through the point 2, 8. F dash of x, which is another way of writing dy by dx. So f dash of x is equal to 6x squared minus 6x. Find f of x. So, there you go. F dash of x just means derivative. So, f of x just means y equals. So, we've got the derivative, we've got a point. Let's go. So let's go with what we know. We integrate what f dash of x is. So we integrate 6x squared minus 6x with respect to x. So we get y equals 6x cubed over 3 minus 6x squared over 2 plus c. So y is equal to 2x cubed minus 3x squared plus c. But we want to work out what that c fella is. So we're told that it goes through the point 2, 8. So we have an x value, we have a y value. Well, let's sub everything in. So let's do that. So we get 8 equals 2 times 2 cubed minus 3 times 2 squared plus c. So 8 is equal to 16 minus 12 plus c. 8 equals 4 plus c, so c is 4, and therefore we stick it back into our original thing. So f of x is equal to 2x cubed minus 3x squared plus 4. And that is that. That is all you need to know with the integration at the very basic level. We just focus on adding 1 to the power, dividing by the new power, and working out what c is. It's a classic exam question to say f dash of x is equal to this, find f of x. And if you follow that algorithm, you'll be absolutely fine. So that is where we're going to leave it for today. If you have found it helpful, then make sure you leave a like down below. If not, then let me know what I can do to improve down below in the comments section. So, thank you very much for watching today, and best of luck with your FSMQ.